Welcome to Luvitex Engineering, where we sketch out the things that keep the industrial world moving. Now, let's start.
You know, have you ever actually stopped to wonder what invisible force powers the robots that are quite literally making your lunch right now? When you see that modern factory footage, you know, the machines moving with incredibly rapid, almost blurring reflexes to perfectly slice vegetables or instantly seal a bag of chips, what exactly is driving all that motion? Well, welcome to this explainer. Today, we're demystifying pneumatic cylinders. We are going to explore the absolutely fascinating, invisible, and highly compressed world of pneumatic systems. And I promise you, by the time we wrap this up, you're going to see the modern automated world in a completely different light. So, here's our roadmap for today. First up, we've got the fluid power showdown, air versus liquid. Then we'll go inside the pneumatic cylinder, see how they're powering your food supply, build out a quick diagnosing and maintenance survival guide, and finally, take a look at the smart automation future.
All right, let's jump right into section 1, the fluid power showdown, air versus liquid.
Okay, let's break this down using a pretty simple analogy. Think of hydraulics as the heavy lifting muscles, right? While pneumatics, they're the fast, agile reflexes. Pneumatic systems use compressed air at relatively low pressures. We're talking typically 80 to 100 psi. Because air is so light and highly compressible, these systems can achieve blazing speeds, up to 100 inches per second. Plus, they're inherently super clean. On the flip side, you've got hydraulics. They use liquid, usually oil, at massive, massive pressures, ranging from 1,000 all the way up to 5,000 psi. Now, because liquid doesn't really compress, it moves a lot slower, generally just 4 to 20 inches per second, but it delivers this immense, unyielding precision. To put that into perspective, check this out. A hydraulic cylinder generates a staggering 25 times more force than a pneumatic one of the exact same size. 25 times! So look, if you need to crush a car or, say, lift a bulldozer bucket, you're definitely using hydraulics. But if you need to rapidly sort lightweight packages on a fast-moving assembly line without making an oily mess, pneumatics win that battle every single time. Which brings us to section 2, inside the pneumatic cylinder. Let's look at the actual anatomy of these actuators. So inside, there are really two primary designs you're going to run into. First, single-acting cylinders. These just feature a single port. The compressed air pushes the piston out and then a mechanical spring returns it. It's a simple, lower-cost design, but the catch is that the spring is constantly fighting that air pressure. Then you have double-acting cylinders. These have two ports and absolutely no spring. The air is used to both push and pull the piston. This makes them significantly faster, way stronger, and honestly far more efficient for complex automation tasks. Now, you might be wondering, how do we figure out the actual pushing power of these things? Well, pneumatic force is simply the piston's effective area multiplied by the system's working pressure. Basically, it's pretty straightforward physics. The bigger the diameter of the cylinder and the higher the air pressure you pump into it, the stronger the push. Simple as that. So when engineers need to calculate the real usable force a cylinder is going to output on the factory floor, they follow these steps. First, you find the effective area, either the thrust or traction. Second, you multiply that by your working pressure. But wait, here's where reality sets in. Actually, scratch that perfect world math. You always have to deduct about 10% from your total to account for the internal friction rubbing against the seals.
All right, let's move on to section 3, powering your food supply. These are the everyday applications you probably don't even realize are happening.
Because guys, pneumatics are literally everywhere in the food and beverage industry. They're the invisible hands automatically opening and closing those massive industrial oven doors in bakeries. They accurately drive the liquid filling plants that perfectly bottle your water and soda. They power those rapid, highly consistent blades, slicing your vegetables and cheeses. They even run the complex vacuum systems that lift and securely package super delicate products. Seriously, the next time you open a perfectly sealed bag of snacks, you should absolutely thank a pneumatic cylinder.
Now, why pneumatics for all this food stuff instead of those super strong hydraulics we talked about earlier? One word: cleanliness. Because pneumatics use clean, filtered air rather than messy, high-pressure oils, they are the undisputed kings of hygienic environments. Think about it. A single drop of leaked hydraulic oil could ruin an entire production run of food. Plus, these pneumatic systems use specialized FDA-approved food-grade tubing like PU Fabuthan. This stuff completely prevents contamination and can withstand the extreme high-temperature sterilization cycles that are absolutely critical in modern food processing.
Okay, shifting gears a bit to section 4, diagnosing common cylinder problems. Let's build your maintenance survival guide.
Let's put together a quick troubleshooting toolkit by matching up some common symptoms to actionable fixes. So if you're out on the floor and you hear hissing, you've got an air leak. That's almost always a worn seal that needs replacing. If you're seeing jerky movement, well, you likely have moisture or oil contamination inside the lines, which means you need to clean the filter and lubricate the system. And if the cylinder is just jamming completely, that is usually a side-loading misalignment issue. And I really want to slow down for a second here to emphasize this point, because side-loading is a silent killer of pneumatic cylinders. These devices are designed to do one thing: push straight out and pull straight back. If the load they are pushing happens to push back at an angle, even a really slight one, it causes the internal piston rod to scrape heavily against just one side of the cylinder wall. That uneven wear quickly ruins the airtight seals. It bends the rods, and it ultimately leads to catastrophic, super expensive system failures.
And when those seals do wear out from things like side loading, you're going to get leaks. Now, microscopic air leaks might not seem like a huge deal at first glance, but they literally force your air compressors to work overtime, draining immense amounts of energy and money. So, to hunt them down safely, you got to follow these meticulous steps. First, always isolate and depressurize the system so you don't risk a high-pressure injury. Second, do a simple soapy water test. Just spray it around the joints and watch for bubbling. That'll pinpoint exactly where the air is escaping. Finally, go ahead and replace those damaged seals or fittings.
All right, bringing us to our final stop, Section 5, the smart automation future. Let's look at the Industry 4.0 upgrades.
You know, pneumatics might rely on old-school physics, but they are getting a major digital facelift right now. By integrating IoT, the Internet of Things, sensors directly into the cylinders themselves, we're unlocking real-time data analytics. This is a real game changer. Instead of just waiting for a cylinder to start hissing or jamming up, these smart devices constantly monitor their own friction, stroke time, and air consumption. They send out predictive maintenance alerts. They're essentially telling facility managers, hey, my internal seal is probably going to fail in about 2 weeks. You might want to replace it during the next scheduled downtime.
And this digital oversight is absolutely crucial because, honestly, compressing air is incredibly energy intensive. Check out this breakdown. In traditional systems, you lose about 55% of your energy just in the compression phase alone. But it gets worse. Another 20% is lost to actuator inefficiency, and a staggering 20% is lost just to leakage. So smart monitoring is vital for closing these efficiency gaps. It lets you detect leaks the literal second they start, and it allows you to adjust digital flow controls so you're only using the exact minimum pressure required for the job.
So, from effortlessly opening bakery doors to seamlessly interacting with advanced AI-driven robots, the invisible power of compressed air is quietly driving the modern world forward. And with smart sensors making these systems more efficient and more reliable than ever before, we have to wonder, as smart pneumatics continue to evolve, what human tasks will compressed air conquer next? Definitely keep an eye out the next time you see automated machinery. Chances are you're looking at the invisible power of air hard at work.
Thanks for watching. For more industrial insights, check out our other videos. Don't forget to like, share, and subscribe to Luvitex Engineering.